Yeah, Borodar, everybody. Thanks for having me along. Yeah, really looking forward to celebrating sort of some of our work, and sort of maybe introducing you to some of the more integrated approaches, which I think we're going to see coming through in the next iteration of the SuDS manual. Really, what we demonstrate as a practice in terms of integrating SuDS into the sort of wider sort of site design is really, it's completely in accordance, and I think in accordance with the ambition of the Welsh national standards around SuDS, but also the new British English national standards around SuDS as well. Getting all the sort of four pillars, expressing all four pillars of SuDS through design. So I'll also introduce you to kind of probably a bit of a rose gallery of stuff that you've seen kind of quite a lot of, and sadly is the kind of prevalent approaches to SuDS across the UK really still at the moment. And I'll start with a couple of questions as well, which hopefully we'll be able to pick up on later. So I'm just going to share screen. Okay, so hopefully, no, hold on. You should be able to see that now. So yeah, today I'm going to talk about what we refer to as integrated SuDS, landscape-led SuDS. Any way of defining it other than the kind of the SuDS which predominantly is being delivered across the UK. And while SuDS has the SAB and its own standards that's been applied for more than 10 years now. And things are better in Wales in terms of the quality of what's being delivered. I still think there's a long way for us to go really to be delivering the kind of SuDS that hopefully we all have the ambition of seeing within a new development. For some reason it's not moving on. There we go. So I just want to start with a couple of questions really, which if you could put in the chat, and maybe kind of Pete could field some of the answers and maybe sort of collate some of the answers, and we'll maybe pick them up later in the chat. But just want to ask a couple of questions of everyone here really. Just have a guess at what you think the average depth of SuDS basins is in Wales. So what's the average depth of SuDS basins in Wales? Just have a stab at that, and we'll kind of pick up on generally what the kind of consensus is, and I'll maybe reflect on that. So drop that into the chat, what you think the average depth of SuDS basins is in Wales. And then the other question to reflect on is how many hydraulically correct SuDS solutions are there, do you think, for an average housing scheme? Let's say a housing scheme of, say, 200 houses. How many possible SuDS solutions, SuDS systems, kind of designs of SuDS systems that get the micro drainage or modeling green tick? How many hydraulically correct solutions are there to the drainage of a typical housing site? And maybe we'll circle back to that at the end of my presentation. So when we talk about integrated SuDS and integrating SuDS design into the kind of wider development landscape, it requires a total mind shift really compared to how we've always conventionally drained development. And that is, I think, one of the biggest, if not the biggest challenge within the industry, is just how different it is from conventional drainage. And so much so we often describe it as taking the kind of lid off your head, turning your brain around, putting it back in again, and then having a go at SuDS. For us, it's a disruptive technology. It's something that is so radically different from how we've always done something. It massively, massively challenges the industry. And I think it's helpful to see it as a disruptive technology, something that is a huge challenge to the industry to get its head around, because then we can start thinking about how we dismantle the barriers that are in the way. So here's just a few points that really are sort of kind of epitomize the kind of the change in approach. One is that we need to see rain as an opportunity, not a problem to be solved, as it has been since the Victorian era. And we see across the globe, we see rain managed in ways that clearly sees it as an opportunity, and we need to see it as an opportunity again. Particularly as climate change bites and we have increasing drought periods in summer, and our green infrastructure and urban environments are starting to struggle, and we're starting to talk about species that we can't plant anymore, and bringing species from other parts of the world because of the dry and hot conditions that we're now planting into. Rain is a huge opportunity to give us climate resilience, to give us drought resilient planting or more drought resilient sort of landscapes. It's an opportunity to create biodiversity and amenity benefits relating to water. So we need to see it as that. This rain, this precious rain that lands on our development, see that as an opportunity rather than treating it as a problem, which is the kind of prevalent mindset. We need to distribute the management of that rain across the site. It lands everywhere in a development. It lands across the whole of a development. So why do we put it all in one hole at the bottom or a couple of holes at the bottom? So we need to distribute the management water as much as we can throughout the development. To do that, we need to repurpose the fabric of development itself. So we need to ask every part of that development, can you manage water? Can that roof manage water? Can that hard surface around a building manage water? Can that green space around a building? Can the green space next to roads manage water? Can the hard surfaces, can the public realm, can all those ingredients that we were going to put in our development anyway, can all of those manage water? And we need to start where rain lands. So we call this source control, and this is really, really critical to unlocking all of the kind of good outcomes that we're aiming for through SuDS design, is starting where it lands. Starting to manage water either on a surface where the rain actually lands or as close to it as possible. If we do that, we'll touch on this later, we protect that environment from pollution and we protect parts of the landscape from regular wetting, which means we open up opportunity for wildlife and multifunctionality for people. So that source control is absolutely critical and 95 to 99% of the time missing from most SuDS designs. We also need to recognize the rainfall hierarchy, the fact that the majority of the time it's not raining. I know it doesn't feel like it, but most of the time it's not actually raining. So these systems aren't even functioning hydraulically. And most of the time when it does actually rain, it's normally small rainfall events. It's very rare, exceptionally rare by definition, that these systems would actually fully fill. So we shouldn't be putting all of our effort into designing only for this one extreme rainfall event. We need to recognize a hierarchy of rainfall events, and we'll touch on that a little bit later. We need to keep water flow in the landscape as much as possible. Our ambition on any site is to have zero pipes. We rarely achieve that. We do sometimes achieve that, but that's the sort of starting point. We want to minimize pipes as much as possible. And if we do use pipes, keep the length of pipes as short as possible so that we can keep the water flow in the landscape as much as possible. Then we have a hugely resilient system with lots of volume losses, lots of water quality treatment, and we can distribute the management of water easily through a landscape in features that people actually want to go into and spend time in. And I think, again, really, really fundamental is seeing SuDS not as an engineering-led discipline, but we would suggest it should be a landscape-led process. We are dramatically impacting sometimes development landscapes in really negative ways with really perverse results because the engineering is seen as the most important thing. But to my mind, and hopefully to others, it's the kind of results are not okay. We really need to be thinking along landscape-led approaches. And this isn't to undermine the importance of the engineering at all, not one bit. A really useful analogy is building design, architecture. The kind of structural engineering of a building, no one would argue that is not critically important part of kind of building design. But the overall building design, the way it works for people, energy efficiency, heritage, all the other aspects involved in designing a building for people is a creative-led process, a design-led process, coordinating between designers and engineers to make sure that the overall thing works in all the different aspects it needs to. We would suggest, we need to take a similar approach for our development landscapes. So bit of a rose gallery. What we're trying to move away from is what variously across the country might be 80 to 99% of what's kind of coming through planning, these kind of end of pipe approaches. So this one was one of two green spaces that were designated as public open space through the planning process. Steep 1-in-1 side slopes down into deep water, dangerous head walls. Again, this is part of the same development. So conventional pipe drainage, picking up all that runoff on a fairly flat site, the pipes getting deeper and deeper, bigger and bigger until it emerges in the green space. And it's so deep that then there's no space to kind of get the excavation. Most of that excavation is just to get down to the pipes, and then you have to dig a bit more to store the runoff to manage the 1 in 100 plus climate change event. And actually, so this was the last slide and this one are both the same development. So both those were pockets of green space that were the only green space that went through planning as the public open space. And within a year or so was deemed so dangerous that these 1.8 meter high railings were put around with danger keep out of your public open space. And these are very typical, this sort of basin like this with a knee rail around it, sort of saying, yeah, we've sterilized this space. We don't expect you to use it. In fact, we're suggesting you shouldn't go the other side of this knee rail because it might be a dangerous space within the public landscape. Bit uninspiring, not the worst, but also could be an awful lot better. And you kind of can't help but think, well, how much more valuable would that space be for people if it didn't have that kind of dirty hole in the middle? Again, the sort of classic, there's a bit of biodiversity here, but that sludgy, muddy water at the bottom, which has got hydrocarbons, heavy metals, and microplastics from all the kind of vehicular areas on the development, not brilliant for biodiversity potentially. These kind of classic concrete head walls of effectively dangerous climbing structures. We've got so many photos of kids playing on these things. There's more than a 2 meter drop down onto hard concrete and sharp edges for kids climbing on these things. We've seen schemes where then part of the water management system is fenced off, dividing communities, totally separating the sort of housing on one side of this green space to the other, with no means of kind of access between them. And we're increasingly seeing this sort of thing where the idea of multifunctionality is just then slap one more functionality onto what is a kind of badly designed basin. In this case, kind of RSPB approved planting scheme using species that are really good for birds, but basically just a kind of glorified hole, really. The same kind of classic public keep out of this space. Not surprised, it's quite dangerous. There's this sort of sump in the middle, which is sort of try and zoom in on. This sort of vertically sided hole in the middle. So whilst the planting might be good for birds, in terms of people and other biodiversity, there's a huge dangerous trap in the middle of that pond. So it's not okay just to kind of plant it with then some biodiverse species and go, well, there you go. It's now multifunctional. It still creates this sort of dangerous feature in the landscape. And this one I've just been tipped off by someone from Homes England about this scheme. So a huge green space taken up by predominantly like a line of basins with these berms in between, and then realizing that to squeeze a kind of play space of appropriate area on here, basically that play space has a ratio of 10 to 1. It's this sort of linear feature, 4.5 meters wide and 45 meters long, on top of a berm, and the rest of this green space is just taken up with these kind of these basins, giving very little. There's no shade, there's no biodiversity. It's very, very sort of sterile, basically sterilized a huge area of development landscape with very, very little amenity or biodiversity benefits. And then this one, which is a flood mitigation scheme, this is a before shot. But it kind of, to me, epitomizes the kind of engineering only focus that is prevalent across the UK. And as I say, I think has shifted. It's definitely better in Wales, but I still think we need to find the ways of making SuDS much more integrated and multifunctional. This is a little river valley, a park in the kind of heart of a town with sort of housing all around on both sides. So a very well used park with this little stream valley running through the middle with all the biodiversity and connectivity of wildlife through there. And there was a bit of flooding in the town, and so the first opportunity to try and solve the flooding was this kind of park that kind of reached right down into the sort of center of the town. And then the solution then to solving the flooding problem for a few houses was basically to take up about a third of that park and create some huge deep vertically sided holes and put a fence around it, and then feel that was an okay solution to do. And it feels like it's a very similar mentality to what's happening on new build. The idea that the hydraulic functionality is more important than all the other aspects of green space and more important than biodiversity and more important than people's usefulness and value of that green space. So why is that happening? And I would say it is that, again, it's this sort of challenge of it being disruptive technology, completely different from what we've always done. Whereas the prevailing mentality, I believe, is how do we modify what we've always done the least amount to meet these new criteria? And it's coming at it from basically the wrong end. And it's what actually we call the kind of bottom up approach. It results in kind of end of pipe thinking, or what we call a bottom up approach. I'll just illustrate that if we take a very simple sort of housing layout. What we've always traditionally done is put a conventional drainage network on it with pipes that get bigger as they get towards the outlet of a site. And we used to be able to collect all that runoff from development and just chuck it off site in a way that protected the site from flooding, but didn't really have any regard for what happened to that water after it left our site. Now, it's not particularly new requirements anymore, but for the last sort of 10, 15 years, we've had this requirement to then put a flow control on that to limit how fast we can discharge water off a site. And the prevailing thinking, the prevailing design approach across the country is to basically model, to create a conventional pipe network, put the flow control on the end of that network and model it and see how much it floods. And this is how some of the training webinars for the modeling software and how some people at university are taught how to model SuDS is just like this. Basically, do a conventional pipe network, put a flow control on, model it, see how much it floods, then put a hole at the bottom of that network to see if that's big enough to solve the problem. Model it again. And if it's not, don't forget to put the head wall on with the dangerous climbing frame around it for kids. And if that's not big enough and you've run out of space within that last green space at the bottom of the site, go up your network and find the next space to put a hole until you've basically managed all of that volume. So yeah, it's what we call the kind of bottom up approach or the end of pipe approach. What I'm going to show you is basically the absolute opposite, what we call the top-down approach, this integrated way of managing rainfall in the development, which then requires source control and requires challenging the fabric of development to manage water as much as possible. Here's a good example of that, a co-housing project. So it's slightly atypical, but it's totally applicable to very conventional housing as well. So in this case, we've got permeable paving in the parking areas here. So where there is the most pollution, we're picking up that pollution and treating it within the permeable paving. And this is at the top of the management train, at the top of the site. It's a very steeply sloping site. And the runoff from that permeable parking, we bring it back out into the landscape as soon as we can. So it's being collected at the 500 mil, 600 mil down, but we're bringing it back out in the landscape as quickly as possible. In this case, down this sort of tile hung cascade, down a retaining wall. And then you can maybe just see that tile hung cascade in the background there. That drops down onto an erosion protection, and then basically this planted area you can see kind of to the right of the both images is a swale. So that then conveys that water through the landscape at the surface of the landscape. In this case, into this pond, and it picks up other flows on its way, and the flow from the roof of this building drops into this pond as well. Right in the heart of development, we created this little ecological feature and amenity feature. And then you can see the pedestrian street we've got here. Again, the runoff from that is being picked up in a rill on the left-hand side. You can sort of see the planting running down in front of the buildings. There's a rill running down there with little bridges across to each house. That is then the water from that paved area is then being managed in the subbase underneath the paving. And I just think I've got an image of that rill here. Yeah, so you can see the rill on the left-hand side, and you can sort of see it running along the street. That sort of strip of vegetation in front of the houses is where the rill runs. And everything up to that point, basically, we've managed day-to-day runoff from all of the roofs. The kind of the roof runoff drops into those rills as well. So all of those hard surfaces within the site, we've managed day-to-day runoff up to about the 1 in 10 rainfall event in all of those features that I've described. But on the right here, you can see the one and only basin, kind of grass basin, on this site. and it's been protected from every rainfall event up to the 1 in 10 rainfall event. So that is the vast majority. That's 98 to 99% of rainfall events won't reach that basin on the right hand side. They're all managed in all these other features I've described in such a way that they protect that piece of landscape from getting wet when it rains. Apart from the rain that lands directly on that grass basin, it's protected from the rest of that suds flow. In a 1 in 10 rainfall event, it will bypass that basin and go to the brook. Anything bigger than a 1 in 10 rainfall event, in the rare event of that happening, that basin will start to fill up. Sorry, let's go back one slide. Oh, no, sorry. And there it is again. So it is the only kind of open green space within this housing development, and it's very, very heavily used by children. But critically, it is not a muddy, boggy swamp that makes it unusable to people. It doesn't have a film of water every time it rains, making it unusable. It's been protected, and it's been protected from the pollution as well. So it's not getting the kind of hydrocarbons, heavy metals, and toxic microplastics from the vehicular areas. And it's also not getting critically misconnections from people plumbing toilets and sinks into their rainwater pipes, because every rainwater pipe on this development doesn't disappear into the ground. It drops into a rill at the surface. So it would be, yeah, you'd be foolish to kind of plumb something into it. It'd be very obvious if you'd just done that. Another scheme here, another kind of co-housing project. Here we converted the design, what was designed as a green roof, we turned it into a blue-green roof. So we're asking the fabric of this development, asking the roof, which was already gone through planning as a green roof, can you manage some of the runoff? You know, if this was a flat green roof, we could have managed the whole 1 in 100 plus climate change event that lands on that roof. We could have managed it on the roof. Because it went through planning with a slight pitch on that roof, frustrating sort of 3-degree pitch, it meant we weren't able to manage or easily manage the full 1 in 100 plus climate change, but we could take a big bite out of that. We could manage up to the 1 in 20, 1 in 30 rainfall event on the roof. So that's a big volume that we didn't need to find space for in the rest of the landscape, which was, it was a challenging site, kind of fairly slopey site. So it took the pressure off having to manage that volume in the rest of the site. And of course, we're losing lots of volume on the roof. So yeah, but the vast majority of rainfall events probably won't even go past that roof. They'll just be absorbed and evaporated. And here we can see them as we move down the site. We've got the sort of paving on the right, the vehicular area on the right with permeable paving in it. That's treating that runoff and storing that runoff in the subbase underneath. The flows from the roof, so any excess flows that weren't managed on the roof can either pass into that same permeable paving, or in some cases pass across to the other side of the wooden barriers on the left-hand side of the road, where that planting you can see in the sort of middle of the shot is rain gardens. So they're managing some volumes in those as well. So we've managed volume on the roof, we've managed volume in the subbase underneath the paving, and we've got kind of managed volumes in these rain gardens. And these are all spaces and materials that would have been part of that development anyway. We would have had hard surfaces, we would have had roofs. In fact, it was already gone through planning with a green roof, and we would have had planting areas. Now we've just changed those so that we can integrate the water management functionality throughout the development. There you've got another view looking back. You can see the rain garden on the right-hand side and the kind of permeable paving. You can sort of see the lines going across the paving where we're taking water flow across to those rain gardens, exploiting the spaces through to the development as much as possible to manage those volumes, splitting those volumes up into multiple features across the site. So we haven't taken up land to manage this water. And ultimately, this all cascades down to the bottom of the site. So the clean water that ends up kind of coming through this system can top up the renovated mill pond, which is majoritively given over to nature. So in the distance, it kind of stretches off and it's all kind of marginal planting and given over to wildlife. But this bit near the kind of the main buildings is then a natural swimming pond. So there's no reason we couldn't do this in every development. We could have ponds that people can swim in every development if we wanted to. But this was kind of part of the brief, is that they wanted this. And this is our final part of our management train. And this basically can increase in depth by 150 mil in extreme rainfall events to store the extra water needed in the extreme rainfall events. But the rest of the time, the vast majority of rainfall events, it's all managed in all of those other features across the landscape. So yes, we've never asked for space for SuDS. We've always been able to use the materials that we're putting in there anyway, and the spaces that we'd expect to be in there, be that grass verges, green spaces, hard surfaces. We use those to manage water, and so we've never created space that is just dedicated sort of SuDS feature, always multifunctional. So I just wanted to finish with, hopefully this will play. Um, Hopefully you're getting the audio. This is a SuDS basin. I just wanted to show this because, of course, this is it most of the time. This is a SuDS basin, but most of the time it's not functioning because it's not raining. What is it doing the rest of the time? And there's basically just kids playing throughout this SuDS basin, walking on the wiggly wall, playing through the grasses. They are, right in the heart of the SuDS basin, chasing each other, doing this kind of lovely social play. And I just think it's just a nice illustration of how genuinely multifunctional, how genuinely beneficial to local communities that the SuDS landscape can be. It can be totally valuable and valued by local communities, but then have the power to kind of then provide these really valuable flood mitigation and water quality benefits when it rains. So uh, that is it from me in terms of presentation, but please do. Hopefully, there's been some sort of questions coming through. And Pete, I don't know if you've managed to pick up on any people's answers to the average basin depth and how many possible SuDS solutions there are. I don't know if there's a kind of a bit of a consensus in the chat to that.
Well, the scores on the doors. Uh,
Uh,
we have an average of Welsh suds basins being estimated at 1.8 meters deep. The extremes are from 1 meter up to 10 meters. There were two
right.
answers of 10 meters, but
Wow.
mostly it
Okay.
was between the sort of 1.5 and 2 meter sort of depth.
Okay. Now that is interesting because I would say when I do this in England, I think the average is about 2.5 meters. That people think the average is about 2.5 meters. So that is good news. That is good news in that as as we kind of know things are better in Wales in terms of SuDS. So that's definitely improvement. But just to reflect on that, I think it's kind of interesting for people to know that actually within our practice, our working sort of day-to-day maximum when we're designing SuDS is 300 millimeters depth of storage, which is a bit of an eye-opener to most people. So that's our working maximum. We are normally designing to a maximum of 300 millimeters depth of storage in our features. Um, Absolute maximum 450. So we will stretch to 450 if we need to, but we're aiming for 300 mil or less. And we've regularly designed things that are only 150 mil deep or even 50 mil deep sometimes in terms of storage, which is obviously significantly different from what most people are experiencing through what's being delivered, within development. But of course, if you kind of imagine that, that is so critical in terms of not needing knee rails around these things, and actually people feeling like I can use that space. That's a space I feel comfortable walking into. It may not even really be perceptible to people that there's a 300 mil drop over however gently you do that. Um, and what that allows us to do is spread the water wide and shallow rather than be apologetic about it and see it as a risk and make it sort of as small and deep as possible to take up as little space as possible. It's what allows us to use all of a green space, a whole of a playing field, and store shallow over that huge area. But we can only do that if we've protected that we've made sure that in day-to-day rainfall, we're not using that space. We don't want a film of water over that whole public landscape, that green space every time it rains. We don't want the pollution from the whole development going into there every time it rains. We're removing that and protecting from day-to-day rainfall events in the top of our system, maintaining that functionality in all but extreme rainfall events when people are not going to be wanting to use that space. Um, and then how many times how many hydraulically correct SuDS schemes? What was our consensus around that?
Well, we only had three answers to this one,
All right,
and
fine.
they range from 10 to infinity.
Nice. Infinity. Yes, infinity is the answer. And I think a lot of people that have maybe experienced going through a kind of a design and planning process of a scheme with SuDS in will have been almost given the impression that there is one SuDS solution, that it can't change. You can't change this. We've modeled this. This is the SuDS solution. And I think it's really, really important for people to realize that there is an infinite number of solutions, of ways of managing that water on a typical development in a way that hydraulically meets the standards. An infinite number of ways of doing it. And so we should not lead with the hydraulic design being the kind of leading process. If there's an infinite number of ways of doing it, we should be designing first and foremost in places that work for people and wildlife, um, and then finding the way that that can hydraulically work. So I think it's really important that people if it's presented in that way as like, oh, this is the solution for the site, to understand that there are many other ways that site could be solved, if you like, hydraulically, and there are many other opportunities available by considering different ways of managing that runoff. Fantastic. Okay, fine. Thank you, everyone.
Well, that actually segues quite nicely into a question from Steph. Liz, I'll come back to
Mm.
you in a bit, but I wonder, Steph, if you could turn on your microphone and camera and ask your question.
Uh, Hi. I was
Oh,
just wondering about the freeboard requirements then, because typically on a scheme we can have
yeah,
up
yeah.
to 300 mil requirements for freeboard. So that obviously dictates the depth of our basins. So how do we manage that and still keep them shallow?
Yeah, absolutely. So when we're dealing with these kind of depths, we're normally talking about freeboards of about 50 millimeters. So it needs to be proportionate. If you're talking about features that are meters deep, then 300 mil freeboard in terms of percentage of depth
Hmm.
might be kind of appropriate. But in actual fact, if you compare something like 300 mil freeboard on a 3 meter deep basin,
Hmm.
you've effectively kind of got like a 10% sort of protection margin at the top. If you'd apply that to a 300 mil deep basin to get that same kind of like extra volume protection over the top, you're talking about a
Yeah.
30 mil freeboard. So in actually a lot of cases, we're providing more additional volume, if you like, above
Yeah.
our designed volume than the equivalent. So
Yeah. So
yeah,
thinking
so
in
so
percentages rather than sometimes we're prescribed like millimeters instead
absolutely.
of a percentage, where we should be thinking more in
Yeah,
percentages.
300 mil just should not be, that should not be appropriate.
Mhm.
50 mil, if we're designing shallow and wide, 50 mil is a
Yeah.
huge level of protection. But, and actually, arguably, there needs to be less protection for these integrated approaches because the more we distribute that risk across a site, the more we manage that water in multiple features,
Mhm.
the less prone we are to failure. Because if we take everything to, the opposite end of the spectrum is everything to one hole with one flow control, with kind
Yeah.
of quite high velocity flows, the risk of that one flow control blocking is
Mhm.
significantly higher than actually the risk of the distributed flow controls blocking. But of course, if that one feature fails, your whole system has failed.
Yeah.
What we're talking about integrated approaches, we're distributing that risk across multiple features. And also we're losing huge amounts of volume. We these systems massively overperform compared to the kind of end of pipe approaches. So arguably, with a 50 mil freeboard, it's at least the same level of protection, if you like. But with the integrated approaches, you have even more robustness and protection against failure compared to the kind of conventional approaches.
Perfect. Thank you for that.
Yeah, no, thanks for the question. It's a good question. Thank you.